Okay, so one way we can think about approaching addition of whole numbers is a set model. So a set model gives us one set of items and another set of items, and so our sum, or adding those two sets of items together, gives us the total number of items in the union of those two sets. So if we take the addition of Jane's blocks, she has 4 blocks in a pile, and we take another pile of Jane's blocks where she has 3 blocks, and we union those two sets together, we have a total of 4 plus 3, or 7 blocks. So just notice that the sets have to be disjoint, so they don't have any elements in common, or we might have an incorrect conclusion. So if Jane moved one of these boxes in between her groups and called them still a group of 4 and group of 3, yet one of the blocks was used twice, then we would not have a total of 7 blocks. Another way we can think about addition is through a number line model. So this happens and is useful for examples where we're talking about length, maybe. So Kenzo has 4 feet of red ribbon and 3 feet of white ribbon. How many feet of ribbon does he have altogether? So another example when we might want to use a number line model might be Laura drank 4 ounces of orange juice in the morning and 3 ounces at lunchtime. If she drank no other orange juice that day, how many ounces of orange juice did she drink for the day? And the way we could model this on a number line is by marking our number line with uniform lengths of 1, and then labeling our length of 4. For, in the first example, Kenzo's 4 feet of ribbon to begin with, and he is combining it with 3 feet of ribbon, which shows us the total length of ribbon. 4 plus 3 lands us at 7. You can't really see it because it's behind my head, but it's 7 here. And then in Laura's case, we have her first 4 ounces of orange juice, and then her 3 ounces she drank at lunchtime, which shows us her total of 7 ounces throughout the day. So when we use a number line model, students need to understand that the sum represented by any 2 directed arrows can be found by placing the endpoint of the first directed arrow at 0 and then joining it to the directed arrow for the second number, but we have to make sure we're not using any gaps or overlaps. And then we can read the sum of numbers. So in that previous example, we had our number line from 0 to 7, and the first length was up to 4, and the second length started at the very end of our first length and went 3. So that gave us 4 plus 3 equals 7. So we have to make sure there's no gaps or overlaps. All right, so if we're going to think about basic addition facts, so starting with our first 10 digits, 0 through 9, we typically might start with students counting on as a strategy. So this is where we start with one number and then we count up the next amount. So if we were wanting to add 5 plus 3 together, then we would say 5, 6, 7, 8, counting on. So I counted up 3. We could also think about 7 plus 4. I'd say 7, 8, 9, 10, 11. 4 more than 7 is 11. Another way that students start to first begin thinking about addition is using doubles. So doubles like 3 plus 3 get special attention. And then we can do doubles plus 1 or doubles plus 2. So for example, if we know 6 plus 6 is 12, then we can use the associative property to figure out what 6 plus 7 is. Well, I know 7 is 1 more than 6, so 6 plus 6 gives me 12, and 1 more than that gives me 1 more than the double of 6, 1 more than 12 is 13. And then another way we can think about starting out with addition is the strategy of making 10. So when we use a 10 frame is usually a rectangle that has 5 circles on the top, or rectangles. And so this is a 10 frame. So I might think of if I want to do 5 plus 7, I might have 5 in my first 10 frame, and then my second 10 frame I have 7 shaded. I can easily make 10 by bringing the first 5 from my 7 over to my original 5, and now I see I have 10 plus 2 instead of 5 plus 7, and I can easily recognize that 10 plus 2 is 12, which is perhaps easier than thinking of 5 plus 7 on its own.